today our first talk will be about some kind of API. Anton is also our one of the oldest speakers actually at the event. And today
I already forgot about it, but it's true. Yes,
and I think it's your third talk already at our meetup. Third talk, because it was GraphQL and then this, and it was something else.
It's a fourth.
Maybe fourth. Okay.
Fourth.
So welcome.
So hello and welcome everyone for this talk. I will be talking today about remote procedural calls. It's a technology or approach to build API. So I will showcase how we use it in my company, how it evolves right now, and basically where it's going. It may be a little bit, I think 40 minutes talk with a little bit of examples. So a little bit about myself. So I'm like full stack software engineer in a company called Spire. It's a global company, but they have office in Luxembourg where I work, and this is data company, you could say. Basically, company built and launched satellites, and then we use data from satellites to solve like different problems. So it could be personally, I work in maritime, so I put a standard title of from my company, and basically we use different kind of data to track ships, illegal fishing, sanction activities. Also, we use, for example, data for climate, tracking ice, ocean winds, weather, aviation, and a lot of other things. So, in essence, my job and my project I used to work is really data intense. So we receive a lot of data, we process a lot of data, and we expose to the customers a lot of data. So our main product is API, and I work a lot with APIs and different kind of technologies. And during my evolution, I also worked with them. So as my latest discovery, I'd say in my personal evolution as software engineer, I started to work more with RPC-based approach, which I wanted to share with you, what I learned and how much I'm excited about it. So briefly I will discuss what is RPC, how it works, and I will cover a few technologies and frameworks right now on the market and try to compare them with what we have. Yeah. So as you know, most of you, I guess, know what means REST, and I think you all started to work with this approach. So who of us work with REST? I think it's like everyone. Yeah, it's oldest, well-known, well-established, very reputable way of building API. So I also was writing on it, but the moment I end up in front-end code, I learned about GraphQL, and this technology actually captured me a lot. So it's one of the few technologies I truly loved and still love, and I still work with it a lot. So I was giving 2 talks about GraphQL here on those meetups, and actually maybe in the end of the year I will give a 3rd talk about streaming in GraphQL and what we learned of building streaming services in GraphQL in production. Also like the public API, which is totally different requirement. So who of you work with GraphQL? I believe less. Yeah, less. But cool, still a few people. So, and in my personal evolution, right now I work mostly with RPC, which is remote procedural call, and a framework called gRPC. So who of you work with RPC or gRPC framework? A few people, cool. So,
it's a P?
Huh?
It's a P or?
Actually, it's my mistake. It should be RPC.
Okay.
Yeah.
I thought maybe it's something else.
Yeah. So for me, those 3 technologies are not competitive to each other. They kind of complement. It's the same way of, you're basically achieving the same thing. You're building API, but they're a little bit different in aspects. So each of them has unique strengths and weaknesses, and it's not correct to say like this is better or this is better. Each of them serve their own needs. So practically speaking, so when you work with REST and you make a request to the specific endpoint and then you parse the result. The idea of RPC, remote procedural call, is very old. It's probably somewhere from the 70s even. It was popular before, but since then it actually faded away and was beyond the radar. So the idea is to make a call on the client look like you're calling a function, as simple as that. What could be simpler than calling a function? And when you have server, on the server you have this basically function, get by ID, and it's being called somehow. So practically speaking, you have function on the server and you register it somehow. Similarly, you register endpoint with router. And when you make a request, it's actually all those arguments, and the request itself is converted to some transport, sent to the server, and then response is serialized and received on the client. In idea, it's very simple and beautiful, but to make it work, so basically it hides a lot of complexity from the developer, so you don't manage everything by yourself. I could not say how many times I wrote custom fetch wrapper myself to handle all the network things which is specific to the application. So very similar things happening here. To make this work, you need to, should be something which manages the complexity of the network connection for you and all the details for it. And here comes the RPC framework. So there's always framework and library which gives you a lot of predefined things, steps, how to basically make the thing work. And the RPC framework is controlling, managing a lot of things. It gives you good defaults, usually out of the box, but it actually hides a lot of complexity. So it's not as raw like in REST, where you can do, when you have control over the network layer. Here it's a little bit more packed, but maybe it's better. So the one principal difference is that usually calling the function is a type thing, because usually you have typed languages. So all RPC approaches has a schema embedded in them. So there's always a schema between client and server, which controls the types. So as a benefit, you give a type, you have a type safety. Then library manages the routing, so it needs to find where is the server actually located and one function is called on the server. Because of the type safety, you have validation out of the box, usually. So to handle transport, it's also serialization, deserialization. Authentication is a feature embedded as similar to HTTP. And usually there is some network machinery which basically makes the thing smooth for you, that you don't think about timeouts, retries, and all of the things. So it's all packed in the library, and you use dependency on the server and on the client. And maybe set up it a little bit, how you need, and voila, you are using it. So I will cover 3 libraries here, which is currently on the market, and show the difference between them. So the first one, so basically the RPC approach was out of fashion and was not popular for the long time, and REST and GraphQL totally dominates the market. And in 2015 or 16, the Google released, so the Google was working on the HTTP2 protocol, and they packed a lot of features they wanted to implement for their services, like binary encoding, channeling, multiplexing, all those performance improvements. But they were actually lacking framework who can make all those features to work for them. And they developed gRPC as a framework for their use, but also they open source it, so it's publicly available, open source, and so on. So it's very high performant network framework. It's used, as you see, Netflix, Google, all the big players, and I believe it should be Amazon actually here too. Sorry, I'm not putting it. But it's used a lot, especially if you have a high performance and you need to scale. In my company, as I said, we process like billions of messages from satellites per day, so it's quite a lot of scale to handle. The primary intent is backend service-to-service communication, but I will handle how it's used on the front end. So how it works? It has actually a schema, and the schema is defined in separate file called protofiles, and the language, it has specific language called protobuf. It's very old language, basically it's like serialization format. It's from 2000s. It was developed independently, but right now it's used in gRPC. So you write a schema, and it's fully language agnostic. So it's basically service definition. I will show a little bit later. Then you compile it, and you compile could be one or multiple languages. So the client and server could be actually totally different languages. Python and JavaScript. I set it as a Node.js, but it's just for simplicity. So when you have schema, which defines the service, you generate a client stub and server stub. It's specific code pre-generated for you. A client stub is a fully generated client, which allows you to call the functions defined in a schema. So basically it will be somewhere class with the methods defined here, and those methods will be calling the server stub. Server stub is like specific kind of placeholder where actually after you can add your functions to implement. So of course it doesn't provide you implementation, you need to write it by yourself. So here is a simple example of protobuf. You define the service, and then you define the functions like RPC. So name of the function, say request returns, say response. And basically for request and response, you define the messages. So this is purely simple thing. So as you see, it defines the schema, the service schema, all the message formats, and it's also defined how the things will be serialized. You, as a developer, you write only this thing and then compile. That's all. All the serialization, deserialization work for you. So on the client, you have this client stub, and basically you just add it as a dependency or link it somehow, and then you call it. On the server, you have generated stub, but then you need to write your implementation of what you need. And it goes this way. gRPC works only HTTP2 and utilizes all the features. The protobuf generates code for you for the serialization, deserialization. gRPC core is handling all the network retries and all the machinery. And generated stub is the files from the previous slide. So basically gRPC has a lot of functionality and a lot of features because it's basically a Google framework. So they need to solve a lot of problems for their own needs and for their own scale. I will cover performance a little bit later, but I could say it's really performant. It has a bunch of features, which could be a good benefit for some of the engineers, but also could be disadvantage if you would like to start, in 5 minutes, give me a setup and go on. Basically, all the things is happening in gRPC core, and if there is some feature needed for Google, they will implement it first for themselves. So you have a little bit less control over it. I will cover them a little bit later. Just wanted to complete with the features. So gRPC out of the box support 4 modes to work. It's basically a simple request response, streaming from the client, streaming from the server, and bidirectional streaming. So this also really increased the range of functionality because you could have streaming without any problems. It's easily embedded in the framework, and in my company we use a lot of streaming when you basically need to stream data for the customers for a long time, and it's very useful for us. So the Google implemented a lot of features which increase functionality. I tried to find, preparing the talk, I found few benchmarks from Microsoft, from several of them, which covers the performance between them. And for a lot of them, basically, it was ranging from 5 to 10x performance in the speed of only network layer. So the HTTP the simple REST HTTP1 response and gRPC request response will be different, and gRPC will be few times more performant. It will be more performant because of protobuf is a binary format, it has very efficient serialization, deserialization, and it's utilized a lot of HTTP2 features. For example, they have flow control in a gRPC channel on the top of the TCP flow control, so it's quite advanced. So personally, I could not write such code by myself. It's really network machinery. But it's a just example that it could be better used for if you really need to have a scale and load. So covering the front end. So gRPC is unfortunately not working easily on the front end because it's full HTTP2 functionality. So to make it work on the front end, there is some workaround which exists like so you actually can write generated code, JavaScript code, and use it from the browser and make gRPC requests. But it will be actually converted as HTTP1, and then you set up specific proxy, which convert them to HTTP2 format, and then you can reach your gRPC server. So this is a little bit tricky and complicated, and probably should be used as a last resort, or when you really need to reach from the browser to server. So before going next, I would like to demonstrate quickly how we use it in my company. Just a few slides. I will show example in Go because it's my primary language, but this will be easier. So, like I'm sorry. Okay. So we have specific repository which stores only schema files, and to show you, for example, we have proto files related to the ports. So this is a service which returns you the port polygons. So we have database of the worldwide ports like Rotterdam, Hamburg, China ports, and like all of those polygons. And this is a very simple service. It has a single operation, get port polygons with a request, and response is just array of port polygons. So the message is really simple: port polygon, ID, name, so the polygon itself, center point, country, and so on. And we compile it. So we have a setup compile, and when it's done, basically it's generated Go code. Here it is.
Sorry, Anton, could you zoom in a little bit?
Sure, absolutely. So it's generated Go code. It's not fully readable. It's basically not really supposed to be readable by human, but it works. And this code is, as I say, the client and the server stub. So we have a server which implements the functionality, and what we need is to basically, here we have a function. So we have just a service object or service class, and on the service class we just implement this function, and basically when the service is deployed, the gRPC machinery is able to find the request from service to client. Yeah. We do have a little bit of machinery in terms of how we set up client. So for example, when we open new gRPC connection, we set up like timeouts. We capture the errors ourselves, and basically we have a little bit more elaborate setup, but it actually could be working out of the box for sure. Okay, coming back to presentation. Play from current slide. Okay, So the next library is actually called Connect RPC, and it was designed to address problem gRPC had. And the main problem is that gRPC is first hard to use in browser, and second, it's actually not public API. Not say it's if you have a gRPC server and basically it's available, you cannot make a HTTP request to it. So you need only to use gRPC request, which is specific form of request, and then specific tools, and things get complicated. So it's a commercialized framework in terms that there's a company which open source it, but they kind of backing up and try to also provide the kind of make money out of it. It's a very new framework, just 1 and 2K stars, but I like the idea. So what they're actually doing? They develop library, and when they generate the call, so they also use protobuf as a schema, but when they generate the client and service, they allow client and server to receive HTTP requests as well. And this makes things more versatile. So from the browser now you can easily reach gRPC server or Connect RPC server. You can use curl, fetch, but because the Connect RPC also supports their gRPC, you can use old gRPC clients and also make connection. So it's more versatile and more allow you to this polyglot thing when HTTP server can call gRPC server and these things. We are not using it yet, so I give it some time to fail. But if it will not fail, then I can actually I have a few front-end applications which actually can call our gRPC services directly. So maybe we'll use it in the future.
So you would mix them up?
Well,
libraries. You would use gRPC for the backend?
Yes. My idea is to have our gRPC services which work in the backend. They work fine, zero problems. And in my browser, currently I have a browser which makes the GraphQL calls, and then GraphQL calls is converted to gRPC.
Yeah.
It's a typical.
Especially since the problem with gRPC is the front end.
Yeah. So actually, for me, I would call the things directly, especially for the simple calls. And this library allows me to do so without hassle, kind of. I will just need to change the client on the gRPC, but it's maybe one, two services affected. But it's kind of just you can clearly see that it's like new iteration when people who have difficulties with gRPC, they kind of see it and think, okay, how we can improve, how we can make it like next step, and you can clearly feel that they addressed all the problems. Also, it has way easier setup. I'm covering it here. They also say, okay, gRPC is too performant, but too complex. Let's make it simple. Let's make it interoperable between different protocols. Let's write very nice documentation. Let's make it work for the web. And of course, let's add TypeScript, because everyone loves TypeScript.
Sorry.
I will show example also a little bit later with and the third framework I would like to cover today is called the RPC, or TypeScript Remote Procedure Call. It was released a little bit later. Actually, also I found it was released 2016, but ChatGPT actually said it was released to 2020. So I'm not sure about the date. This framework is it has actually GraphQL inspiration, but idea is simple. You have a TypeScript on the server, you TypeScript on the client, and schema TypeScript on the server could be actually a schema between, like a contract between client and server, and things would be easier. So it's also commercialized framework in terms that there is a company behind which tries to which maintain it, but also making money out of it. It's actually getting popular, so 32K, and I think they were actually investing some in marketing. A few years ago, I remember was like a lot of talks about them, so they tried to. So idea is, if you work with a GraphQL, so in GraphQL there is two ways of making it. So the first one, you write a schema and generate the resolvers out of the schema. Or a second idea, you write resolvers like a code and then generate schema out of it. So this takes actually a code first approach. Then on the server you write in a TypeScript the definitions of the functions, and the things are just generated for the client. And it works only TypeScript to TypeScript, but if it's set up properly, it gives you instant compile time, basically instant. You feel like you work in the same code base. Okay, just a little bit demo for the both projects. So the Connect RPC is all the time forget. We almost completed. So the
it's gone.
no, it's here. Yeah. So I just refer the doc, but I will walk through to them very quickly. So you also have schema. So here is a protocol buffer schema, and it's for them it's already compiled. So you see you add as an import dependency the service compiled schema. It's setting up the client. Then you set up the transport and making the client. And basically on the client, you just start. Okay. So having client, you just like call it, and the service has one function called save. So I think it's the full code is here. So it works way simpler. It's really well designed for the front end to use with ease, and has some extra features to work on. So the TRPC is probably, like even this video could show you. You can like work almost instantly. So in terms of the docs, so you on the server you create a router which routes the requests, and then you add some procedures. So this is thing. You basically add a function called user list. You say that it's a query, means like a GET request, and then you write a body. And from this definition of the code and the types here, the client will be generated, and you can use client. Oops. So as features of the TRPC, unfortunately, or maybe for the good, it's TypeScript to TypeScript. So and the code is defining schema. It has inspiration from the GraphQL, so it has like GET queries, mutations, post, and subscriptions over the WebSockets. And it's not as efficient, it's just simple HTTPs and JSON. From the features, it actually has request batching. So if the several requests then within a short period of time, it batches them automatically. And type safety, of course. So if you are a single ninja working in monorepo, it will be probably the best choice. So as a conclusion, this is a popularity of the most of the main API libraries. So the green one is Axios. So I took HTTP client, but any of them is actually have the same dynamics. So you see the HTTP is still the king and nothing. It's actually 5 times more, so 50 million downloads. Second actually comes GraphQL, which is red. So it finds its own niche. It's used. Third one is actually gRPC.js. in popularity. So it means that there's still usage of gRPC.js for not services. It's almost as popular as GraphQL, which is good. So it's kind of used by community. gRPC web is near zero, and the TRPC client is also almost that, near zero. I did not include Connect RPC because it's too new, so it's also very, very low in popularity. But I guess this shows you that you can use gRPC.js freely, like without any problems. Okay, so I think when it comes to the benefits, the biggest one is actually type safety, because you have schema and the things are packed for you as a good default. But in terms of gRPC, you also have great performance. Also, gRPC, the RPCs usually bucket several modes, like streaming or queries, and you don't need to think how to actually implement it or choose the protocol. Usually, developer experience is good. If you break the schema, you will have compile errors. So it has a good one. The disadvantages, I think it's still developing. So the first push was like a few years ago with gRPC, and right now we kind of see next iterations of the libraries that can develop best practices, community, writing documentations. All of those things are important, and it's not yet there. Also, gRPC or RPC is more difficult for the public APIs, which is a problem. Also, coupling between client and server become tighter, so this could be also a problem. You need to actually say, okay, I'm using this framework and I'm full with it. But with HTTP, it's easier. You can write endpoint and then everyone could call it. So it's no locking here. So the setup could be challenging, and non-JSON formats also could be challenging in terms of gRPC. So you need to, for example, you need to set up Postman or Insomnia to make gRPC request. You need to load the schema there that it actually could show you the operations and then write things. So it's kind of not you need to learn it. There is some learning curve. So as a use case, it's a perfect for service-to-service communication, especially RPC or tRPC too. When you have full control of the client and service, when you have high performance, especially in gRPC, or when you have a polyglot application, when the services are written in different languages and you need to connect them together without hassle. So then protobuf works amazingly. Yeah, that's it. So it's done for me. Any questions? Yeah.
So there is one, I heard about one other protocol for doing remote procedure calls, Apache Thrift.
Yeah.
Maybe can you give a brief comparison with gRPC, with Google One?
Apache Thrift is a serialization format. It's basically it's analog of the protobuf. So in Apache Thrift you also similar write a schema, and then it's basically compiled to the code, which knows how to serialize and deserialize this data structures. They were competitors at some time between protobuf and Apache Thrift, but overall probably the protobuf won. So it's a just different way to serialize things, but they are very comparable in features. They both have forward and backward compatibility, so it's basically the same in the end. But the gRPC, I think gRPC is not supporting Thrift.
You said it cannot be used for public APIs. Why is that?
So, like, what is public API? So your customers need to reach you, and without any problems. So you need to expose your API, make it DNS resolution, and like all of those things. And for the customers, they usually, like in this case, the HTTP is simpler because you can expose endpoint and any customer can make request and get this endpoint. And on the endpoint, you can set up rate limiting, all of the proxy caching, things that's already developed for you. You kind of allow a lot of wisdom. When it comes to the gRPC, especially, so your service is exposing a single endpoint. I think it's like /gRPC something, so it's like a cryptic endpoint. And then basically every request coming to this endpoint, and then gRPC core is routing it to the specific function. So this endpoint, when it's exposed, it's not HTTP, you cannot send a JSON there. It will not work. So it's a HTTP2 thing, and it accepts only binary thing. So to make request to this endpoint, you need to have this generated client. And you probably can send your clients this generated code, but I believe it will be way more complicated for them. Also, then another consideration comes like rate limiting or caching. So it's way less knowledge how to build public API with gRPC. I don't know say it's impossible probably, but it will be very difficult. Or more difficult than with RPC. Oh, sorry, with HTTP.
If I remember correctly, so it was another question. No? If I remember correctly, there was a limitation on protobuf message size, right? Like
Maybe.
how much data you can serialize, you can send, if you're aware of it.
No.
Have they faced it ever?
No, we never faced. I cannot recall. And I remember there was like a limit on numbering, like you need to number all the fields, but don't remember about message size.
But I think long request it's still not good. Yeah, the question there.
Does gRPC rely on some kind of TypeScript runtime in the browser, or it's like schema only integration?
So to use, so you ask about gRPC.
gRPC.
Okay.
TypeScript.
I think right now, so this code. So you have a gRPC, you have protobuf schema, and right now I think actually you can compile it to the TypeScript. So I think it's possible, but you need to set it up, this thing, to let it work from the browser.
So if I want to use gRPC in browser,
This work fine. There's no problem.
so without TypeScript runtime, right?
When the TRPC requires TypeScript on the both ends.
Yeah, so they just they require anyone who wants to use gRPC to have TypeScript runtime in the browser, right?
No, it's you need TypeScript when you're developing, because they develop like specific tools like a language server or something like this, which basically runs in the background while you're coding and compiles the project. So, I mean, when you run it in the browser, it's a JavaScript. It's not a TypeScript so anymore. But when you're developing, when you're a developer, if you change something on the server, then you will have compile error on the client because it's asynchronized and connected. So it compiles in the background, like with the developer tools.